And with that said, we have reached the concept of man-made satellites. Man-made satellites are machines designed by us humans to be launched and orbit Earth or other bodies of space. Satellites send signals to TVs and phones all around the world, help predict weather and climate patterns, and also provide satellite images that are useful for scientists studying astronomy. When constructing a satellite, it must be built to the lightest weight possible so that it is easier to launch as the energy required is less. The method to determine the minimum energy required for a satellite to launch into space uses the following gravity formula. Where g is a gravity constant, capital M is the mass of Earth, little m is the mass of the satellite, r is the radius of the Earth, and a is the altitude of the orbit. Basically, this formula uses the gravity acting on Earth to try to find the minimum energy required. Earth's gravity is the factor that is pulling the satellite down, which restricts it from launching upwards. If enough energy is produced, then the satellite will take off.
Once the satellite is launched into space, scientists need to calculate things such as orbital speed, acceleration, and orbital period. Orbital speed. The equation to determine the orbital speed of a satellite can be given as v is equal to the square root of g times m central over r, where v is the velocity or orbital speed of a satellite, g is the gravity constant, m central is the mass of the central body that the satellite orbits, and r is the radius of the orbit for the satellite. This equation can be derived from a number of different steps. Firstly, consider a satellite's mass, which is orbiting a central body with an unknown mass. If the satellite moves in a circular motion, then the net centripetal force, the force that makes the body follow a curved path acting on it, is given as the following, which is a result of the gravitational force acting on the satellite. This can be represented as, since the gravitational force is equal to the net force, we can make the two equations above equal to each other. Once we simplify the equation, once we get the square root of the equation, we end up with the orbital speed of a satellite.
Acceleration equation. The acceleration value of a satellite is equal to the acceleration of gravity of that satellite. Since the equation of the acceleration of gravity is g equals g times m central divided by r2. The acceleration of a satellite in a circular motion is also the same.
Orbital period. The period of a satellite and the mean distance from the central body are related by the following equation, where t is the period of the satellite, r is the average radius of orbit for the satellite distance from the center of the central planet, and g is 6.673 times 10 to 11 newtons times meters squared per kilo squared.
As you can see, mathematics is a huge part of developing our understanding of space. Space is so out of our reach that mathematics is one of the only ways we can concretely wrap our heads around such vague concepts. Whether it be using the simple distance speed time formula to calculate the velocity of planets, or the more complicated concept of parallax, we can see the huge role that mathematics plays in some very key concepts such as orbital lengths, speeds of planets, and man-made satellites.